Alright, so let's take a look at this problem. Once again, we're going to do some things side by side here, and this looks a lot like our first example, but there's going to be one difference here, and you'll see what I mean in a second. So, just like before, we first come up with the common denominator, which this one's been taken care of for us. 8/3, 2/3, so we can subtract right away. Once again, we only work with the numerator. 8 minus 2 is 6, and then recopy our common denominator. Now, you'll notice here that this is a reducible fraction, and normally we would just reduce it right away, but I'm going to put in this extra step because I just want to write out what we're actually seeing here. What we're seeing is that we know that 6 is 2 times 3 in its factored form over 3, and then anytime you have common factors top and bottom, they can be canceled out, and that's why we get the 2. Now it's important to understand what we're doing here because that's going to apply to this problem, but it's a little harder to see it. Here we've got two rational expressions which we're going to subtract, and just like over here, they've been nice enough to already come up with a common denominator. A little complicated, but as long as they're the same, it doesn't matter. So what we're going to do here is subtract. Now, one thing to be careful about with subtraction, which we didn't have to worry about with addition, subtraction is the main operation here. So when I take this 3x plus 4 minus 2x plus 1, every time I want to use this subtraction, here's what I mean. 3x minus 2x is 1x. And this plus we're going to treat like a positive. So positive 4 minus positive 1 is positive 3. But every single time I did that and I subtracted the like terms, I was using that subtraction symbol in the middle. Alright, now recopy our denominator. And there we go. Now, most people would stop right here, but we have to do like we did in this problem here. We have to see, are there factors that the numerator and denominator share in common that we can cancel out? But here it's not that obvious. So what we have to do is we have to ask ourselves, is the numerator factorable? X plus 3, with all we've done with factoring, I'd say no. X plus 3 is its own factor. But then if you look at the bottom and you were to go through all the different ways we have to factor through our factoring checklist, it does turn out that this does factor. 2x squared was originally 2x times x. Negative 3 was originally a minus 1 times a positive 3. And specifically arranged like this because in the middle here, inner, negative 1x, outer, 6x, negative 1x plus 6x is 5x. And now we see that this did have common factors. X plus 3 on top as a factor cancels out with the x plus 3 on the bottom, and we get a reduced fraction with 2x minus 1 on the bottom. And of course we can't leave the numerator blank, so we fill it in with that invisible 1 that's usually invisible factor of 1 that's normally right there, and that becomes our reduced answer, just like we came up with the reduced answer over here. So that's an additional step that you're going to have to start doing, is that you're going to have to see if you can factor the top, factor the bottom, and do any of those factors cancel out so that we can reduce the fraction.